Next chapter, logarithms. The logarithmic notation. Consider 2 multiplied by itself 5 times. We write it as 2 raised to power 5. We said that this is an indexed number. 2 is a base and 5 is the index. If we complete that and give the answer, we shall have 2 raised to power 5 is equal to 32. In logarithms, 2 is still called a base, but now the index 5 is called the logarithm. We say that the logarithm of 32 to base 2 is 5. Mathematically, we write log to base 2 of 32 is equal to 5. 3 raised to power 4 is equal to 81. This means the logarithm of 81 to base 3 is 4. And so we write log to base 3 of 81 is equal to 4. 10 raised to power 3 is equal to 1000. And therefore log to base 10 of 1000 is equal to 3. 5 raised to power 0 is equal to 1. And therefore log to base 5 of 1 is equal to 0. In general, if b is equal to a raised to power n, then log to base a of b is equal to n. For example, find the values of n in the following. Log to base 5 of 625 is equal to x. Log to base x of 1296 is equal to 4. And log to base 3 of 3x squared is equal to 6. In the solution, log to base 5 of 625 is equal to x. In index form, we shall have 5 raised to power x is equal to 625. We express 625 as a product of its prime factors. 625 is equal to 5 raised to power 4. And so 5 raised to x is equal to 5 raised to 4. The bases are the same, and so we equate the indices. X is equal to 4. Next, log to base x of 1296 is equal to 4. In index form, x raised to power 4 is equal to 1296. We find the fourth root of each side. The fourth root of x raised to power 4 is x. The fourth root of 1296 is 6. And therefore x is equal to 6. Lastly, log to base 3 of 3x squared is equal to 6. In index form, 3 raised to 6 is equal to 3x squared. 729 is equal to 9x squared. Divide both sides by 9 and we shall have x squared is equal to 81, and therefore x is equal to 9, or x is equal to negative 9. Next, laws of logarithms. The first law, log a raised to power n is equal to n log a. And so log 4 squared is equal to 2 log 4. Second law, suppose a is equal to y raised to m and b is equal to y raised to n. In logarithm form, we'll write log to base y of a is equal to m and log to base y of b is equal to n. It therefore means a times b is equal to y raised to m times y raised to n. Applying the rules of indices, a times b is equal to y raised to power m plus n. Introducing logs, log a times b is equal to log y raised to m plus n. Using rule 1, log a times b is equal to m plus n times log y. Opening the brackets on the right hand side, we shall have log a times b is equal to m log y plus n log y. Reversing rule 1 now, we shall have log a times b is equal to log y raised to m plus log y raised to n. But then y raised to m is equal to a and y raised to n is equal to b. If we substitute this, we shall have log a times b is equal to log a plus log b. And this is the second law of logarithms. Third law, using the same a is equal to y raised to m and b is equal to y raised to n, in logarithm form we'll write log to base y of a is equal to m and log to base y of b is equal to n. Applying the laws of indices, a over b is equal to y raised to m minus n. Introducing logs now, log a over b is equal to log y raised to m minus n. Applying the first law, log a over b is equal to m plus n times log y. And then log a over b is equal to, we open the brackets, m log y minus n log y. If we reverse that rule, log a over b is equal to log y raised to m minus log y raised to n. But then y raised to m is equal to a and y raised to n is equal to b. If we substitute, we shall have log a over b is equal to log a minus log b, and that is the third law of logarithms. Let's see the applications. Simplify the following: log to base 10 of 625 plus log to base 10 of 16. Number 2, log cube root of 5 squared over log square root of 5. Number 3, log to base a of a raised to power 4 minus log to base a of a. In the solution, number 1, log to base 10 of 625 plus log to base 10 of 16. Using rule 2, this is equal to log into 625 times 16. And so we shall have log to base 10 of 10,000, and that is equal to 4, because 10 raised to power 4 is equal to 10,000. Number 2, log cube root of 5 squared over the log of square root of 5. This is equal to log 5 squared raised to power 1 over 3. Cube root is the same as index of 1 over 3 over log 5 raised to power half. Power half means square root. Completing that, we shall have log 5 raised to power 2 over 3 over log 5 raised to power half. Using rule 1, this is equal to 2 over 3 log 5 over a half log 5. We cancel log 5. We remain with 2 over 3 over 1 over 2, which is equal to 4 over 3. Third one, log to base a of a raised to power 4 minus log to base a of a. Using the third rule, we have log to base a of a raised to power 4 over a, and that gives us log to base a of a raised to power 3, and that is equal to 3. Next, solving logarithmic equations. Now, logarithmic equations are solved using the 3 laws of logarithms and also using the laws of indices. The application is diverse and each case has its own merit. Let's take a few examples. 1. log into x plus 4 is equal to log into 2x plus 3. Because we have logs on both sides, we ignore the logs but not cancel them out. We do not cancel logs. And so we remain with x plus 4 is equal to 2x plus 3. Opening the brackets, we shall have minus x is equal to minus 1 and x is equal to 1. That's simple. Second example, 3 log x minus log 2 is equal to log 32. Applying rule 1, we shall have log x raised to power 3 minus log 2 is equal to log 32. Applying rule 3, log into x raised to power 3 over 2 is equal to log 32. We ignore the logs and shall have x raised to power 3 over 2 is equal to 32. Cross multiplication, x raised to power 3 is equal to 64. Find the cube root of either side and x is equal to 4. Again, not that bad. Another example, log to base 3 of 2x plus 5 is equal to a half log to base 3 of 25 plus 2. The first thing we notice is that there is a 2 without log. We need to make it have the log. We simply put the log of a number which is equal to 2, but the number must be to base 3 like the rest. We know that 3 raised to power 2 is equal to 9, meaning that log to base 3 of 9 is equal to 2. And so we can replace our 2 with log to base 3 of 9. That gives us log to base 3 of 2x plus 5 is equal to log to base 3 of 25 raised to power half plus log to base 3 of 9. That gives us log to base 3 of 2x plus 5 is equal to square root of 25 is 5 plus log to base 3 of 9. Applying rule 2 on the right hand side, we shall have log to base 2x plus 5 is equal to log into 5 times 9. Ignoring the logs, we shall have 2x plus 5 is equal to 45. 2x is 40 and x is 20. Another example. Evaluate log to base 4 of 16 plus log to base 4 of 4 raised to negative 2. Recall in indices, 4 raised to power negative 2 is also equal to 1 over 4 raised to power 2. And so we shall have log to base 4 of 16 plus log to base 4 of 1 over 4 raised to power 2. That gives us log to base 4 into 16 times 1 over 16. If we cancel out, we shall end up with log to base 4 of 1, which is equal to 0 because 4 raised to 0 is equal to 1.
I believe with the right resources and help, most people can learn most of the math that they need to learn. But in almost any class that you go into, you need to make sure that you're at the starting point. People come in with different backgrounds, different preparations, and so you're not all on the first day at exactly the same place. And so you can go on and learn math. You may need tutorials, you may need tutors, etc., to get your foundation solid so that you can build the next course on it. But math is not so complicated that most people can't learn high school math and certainly the introductory courses in university.